Video is going to talk about oblique or slant asymptotes. We're also going to be talking about horizontal asymptotes in this lesson, so that will be part of it. To make this go a little bit faster, what I want you to do is notice there's column A, B, and C, and I want you to do column A, which is solve for y using long division. So I want you to do, actually it says long division, you could do synthetic division. So for 1 and 2, you can do synthetic division and set it up. And then, or if you wanted to do long division, you could, whichever way you want to do. So 1, 2, and 3, actually all of them, 1 through 5, if you will do long or synthetic division, 1 and 2, you have to do synthetic. Number 3, you have to do long division. So let's just do 1 and 2 with synthetic, and 3 and on with long division. Take a second, pause the video, and do that. Okay, let's see how you do clear division. On this first one, when I did synthetic division, I got this 2, -3, -6. And remember what that means is 2x minus 3. So 2x minus 3 is what I want to put over here. There is a remainder, but we don't really care about remainders when we talk about these. So we're just looking at the actual polynomial, forget about the remainder. So 2x minus 3. On the next one, I put in a -5. I got 1, 3, and -35. That is this polynomial, but for our purposes today, we just want the x plus 3. Now, number 3, I said you needed to do synthetic, or excuse me, long division. The reason is because we have a quadratic in the denominator. And if you have a quadratic, you can't do synthetic division. You have to do long division. So I do that. It's kind of confusing, isn't it? Because it came out to be a fraction. Because how many times does 3 go into 2? Well, 2/3, because 2/3 times 3 is 6/3, which is 2. So that comes out to be 2/3. And again, the remainder stuff, we don't really care about that for right now. We're just going to deal with our 2/3. Number 4, again, we have to do long division because we have x squared going into x. When we do that, we get an even stranger fraction, 1 over x. I'm going to put 1 over x here. I'll explain this in just a second. And then over here, again, we do our division. We get x squared. All right, what do all these numbers mean? Well, let's go back up to the top. I would recommend that at the top, you write this above the column because whatever goes on down here in this column is going to tell us what is a slant asymptote or the horizontal asymptote. So on number 1, we have a slant asymptote or an oblique asymptote of 2x minus 3. What does that mean? Well, it means that if we graph the point 2x minus 3 and we make that into a dotted line, there's going to be an asymptote there. So we're going to have an asymptote that looks something like this. All right? Number 2, similar deal. We have an asymptote here, so we can graph that. And we graph it like this. All right, what this is telling us is that if we get a polynomial with our synthetic division or our long division, and that's a linear function, that is the slant asymptote. So we have a slant asymptote here, we have a slant asymptote here because we did the division and we found out. Now, the next one, when we did the division, we didn't actually get a line. Well, we did get a line, but it's a straight line, a horizontal line. It is a line at y equals 2/3. That is a line that is right about here. So in this case, rather than having a slant asymptote, we have a horizontal asymptote, whereas these two were slant or oblique asymptotes. Okay, number 4 is even stranger because it is a fraction, but it's 1 over x. Well, we know, do you remember that the graph of 1 over x looks like this? And that had a horizontal asymptote at y equals 0. And so this is going to have a horizontal asymptote at y equals 0. So if it comes out to be 1 over x, we're going to do it that way. Well, what about if it comes out something different than that, like x squared? Well, that we know that the final result would be a quadratic, a parabola. That doesn't have a horizontal asymptote. So that if it comes out this way, it doesn't have horizontal or oblique asymptotes. Let's go back and graph each of these and take a look at what they look like. So once again, I'm going to have you pause your video, and what I want you to do is factor anything that can be factored. For instance, I will get you started off, and I know that this factors as 2x plus 1 and x minus 3 over x minus 1. And then from that, I know some information. I know that I have a 0 at 3, and I have another one at -1/2, and I have a vertical asymptote at +1. Okay, so this is going to give me some clues. Do that on the rest of these. Factor whatever can be factored. If it can't be factored, just leave it. But factor what can be factored. Figure out where are your zeros and your asymptotes. Okay, hopefully you've had a chance to factor these. Let's take a look now at how we would graph these. So as mentioned, these are the zeros. This is the asymptote. The asymptote has a power of 1, so it is an odd asymptote. And then our end behavior, I'm going to take a second to talk about the end behavior. 2x squared over x would reduce down to just a 2x, which would be a line like this. So my end behavior is down over here and up over here. So it's going to connect this point. It goes through it because there's no power. And then it's going to get closer and closer and closer to the asymptote. Now I'm at the vertical asymptote. The vertical asymptote has a power of 1, so it's odd. So it's going to have to come all the way down here. It's going to go through this point and get closer and closer to the asymptote. And if I double check my end behaviors, down on the left, yes. Up on the right, yes, I'm good. All right, next one has a x-intercept at -10. I had to extend my graph over here, and also at +2. My end behavior, again, is going to be x squared over x. So that is x, so it's going to be similar to what it was a second ago. That is, it's going to go down on this side, get closer and closer and closer to that asymptote. That should be kind of a straightish line, kind of a curve, nice curve there. Goes through that because there's no power. And then first power on the bottom, that means we go down here. We come through this, it gets closer and closer. It's not a beautiful graph, but it's going to look something like that. This one was tougher. In fact, this one was downright confusing, wasn't it? Because for one, you could not factor this. So I know what the vertical asymptotes are, and now I know what the horizontal asymptote is, but I have no idea really any other points at all. To find these, I would have to do the quadratic formula because I can't factor it. And as it turns out, the quadratic formula is not helpful because it gives us imaginary answers. Not very helpful. Okay, what do you do when you're totally stuck? You don't know how to graph anything. Well, what you do is you create a table of values. And so I can create a table of values. That's a Y. And then I'm going to show you where it is on Desmos too. But let's start off. Table of values, what should you even put in? Like, where do you go? Well, let's pick something on this section. That's a -4. Let's pick something in this section. I could pick 0. I'll pick 0. Or I could pick 1. I'm going to put 0 and 1 both in there. And then over in this section, let's put maybe a 4 in this section as well. So when I plug these in, how do I do that? Well, the 0 is easy, thankfully. It's -8 over 27. 8 over -27. That is a fraction. It's a negative, and it's just down here a little bit, kind of like this. You know what? Let's forget the rest of the table of values for now. I'm just going to deal with what I have. It's going to hit this point. It's never going to hit the axis because, well, it's just not. If I plugged in like a -2 and a 1, it's not going to. And if you wanted to put those into your table, you absolutely could do that. It's going to do this, okay? It never actually hits the, because remember I said if you tried to do this, you'd have to do a quadratic formula, you'd get imaginary answers. It never hits the axis, so it has to turn around. So it does that. Now, where do we go from there? Well, on these asymptotes, they are both odd asymptotes. That means opposite sides. So this one's down here. This one's going to have to come up here. Same thing over here. It's odd, so it's down here. It has to come up here. This is the graph for number 3. And here it is in Desmos. I went ahead and put that into Desmos for you, and this is what it looks like, pretty close to what we had. All right, you can see the y-intercept is right there, and that's the only point that's actually a point, right? The asymptotes were what gave us the clues. Now, the end behavior, interestingly, the end behavior comes from the horizontal asymptote in this case. So the end behavior is 2/3. Is y equals 2/3. So as x approaches negative infinity, y is approaching 2/3. And as x approaches positive infinity, y is approaching 2/3. So 2/3 is our end behavior. It is our horizontal asymptote. That's where it's going to get closer and closer and closer as the graph goes to the ends. Okay, this next one I might actually do the table like I said a minute ago. So we get 1 over x, we factor it, we get our asymptotes. And again, we don't really have any good information. If I plug in a 0, interestingly, I get 0 over -6, which is 0, 0. But I'm supposed to have an asymptote there, so what's going on? I'm going to go ahead and put that 0, 0 there because I actually know it is there because I've done this before. So it seems weird, but here's the deal with horizontal asymptotes. It can touch it and go through it. It just can't stop on it, if that makes sense. So I'll show you. So back to that concept of a table of values. What if we did a table of values? Let's pick one over here, like -3, and we'll pick one in here. Well, we already did 0. Let's pick another one, maybe 1. And then over here, maybe a 4. All right, if we plug these in, and I did this a minute ago, I plugged these in, and when I plugged in a -3, I got a -1/2. I plugged in a 1, and I got a -1/6. And I plugged in a 4, and I got 2/3, and that was really confusing to me. I was like, what the heck is going on? So let's take a look. -3 and -1/2 would be down here. 1, -1/6 would be down here, and 4, +2/3 is going to be up here. All right. Ooh, kind of confusing. What's going on? Well, our end behavior, once again, our end behavior is y equals 0. It's going to get closer and closer to the 0. So that means it kind of looks like what means it's going to be, this is going to be over here. It's going to be one of those kind of L shapes. And then this vertical asymptote is odd, so it must come all the way up here, but it's supposed to go through that too. So this is the strange part that you would not have just intuitively known about. But here's what it looks like. It can pass through the horizontal asymptote. It just can't like rest on it. I know it's the horizontal asymptotes are a little strange. I agree, give you that. Next vertical asymptote is odd end behavior. If it's odd, it has to go up here. So it's going to come up here, it's going to hit this point, and it's going to get closer and closer and closer to the asymptote. All right, that one was strange, right? The main thing we're looking at is horizontal asymptotes and slant asymptotes. It has a horizontal at y equals 0 because when we did it, we got 1/x. Let me show you what it looks like on Desmos. Okay, here it is on Desmos. See, it goes this little piece down here, goes through there oddly, and then there's one part over here, which is what we had, and that table of values helped us come up with that. And to get that table of values, I just plugged in numbers, and I decided what the numbers plugged into as. All right, this one, we definitely do have a 0, 0, because it's okay to have that 0 here. There's no asymptote. When we come up with an x squared, that's like a parabola, right? Anytime you come up with something like that, there is no horizontal or oblique asymptote. It actually doesn't happen. And the other thing that happens with this is it is a 4th power. So this one was a 1st power. It had to go through. That's why it went through. This one is a 4th power. It has to bounce. So this is going to bounce. Our end behavior is still this, is on our end behavior. So this side is going to be like this. Then our asymptotes are both 1st power, so it's opposite. So it's going to come over here. It's going to bounce. And it's going to go opposite. And our end behavior has to end like this, so it does. Let me show you on Desmos. All right, on Desmos, I'm going to have to zoom way out like this. Do you see there's like a floater up here on the left? This bounces down here. There's a floater up here on the right. If I just go by normal zoom level, all I see is this. So I had to zoom way out to see those other pieces, and there they are. And so that matches up pretty well with this. Okay, let's turn the page because there's some important information on the next page. All right. This is the summary that you need to write down. If the degree of the numerator is equal to the degree of the denominator, it is the leading coefficient of the leading coefficient. If the numerator is less than the denominator, we have a horizontal asymptote, which is y equals 0. That's the x-axis. If the numerator is greater than the denominator by 1 power, then it is oblique. We have to do long division. And if the numerator is greater than the denominator, there is no horizontal or oblique asymptote. Here's the thing. You have to either memorize these or you just have to understand how to do that division. Because remember, on this side, we did long division to figure it out. And that's how we knew whether we had to divide or not. And that's how we knew whether we had a horizontal instead. So the long division you can do, or you can memorize these rules. Neither one of them is super easy. you memorizing or long division. That are not great options, but those are the options we have. Let's just take a look at these examples using these rules. Notice this one. If I did long division, I have x squared over x. That's going to give me an x. That's going to be a slant asymptote. So I should do long division with this one. This has an oblique asymptote. I would have to do division to find it. This one, number 2, comes out to be x over x squared. That reduces to 1 over x. That means it has a horizontal asymptote at y equals 0. This next one, 4x squared over 2x squared, the x squares cancel and we get 4 over 2. That's 2. That means we have an asymptote, a horizontal asymptote at y equals 2, leading coefficient over leading coefficient. And this last one, x to the 4th over x squared, that reduces down to an x squared. That means there is no horizontal or oblique. All right, we're definitely going to have to practice this in class next time.